Mercury has the most eccentric orbit of all the planets in the Solar System. Its eccentricity is 0.21, with its distance from the Sun ranging from 46 million to 70 million kilometers, 29 million to 43 million miles. It takes 87,969 Earth days to complete an orbit. The diagram illustrates the effects of the eccentricity, showing Mercury's orbit overlaid with a circular orbit having the same semi-major axis. Mercury's higher velocity when it is near perihelion is clear from the greater distance it covers in each 5-day interval. In the diagram, the varying distance of Mercury to the Sun is represented by the size of the planet, which is inversely proportional to Mercury's distance from the Sun. This varying distance to the Sun leads to Mercury's surface being flexed by tidal bulges raised by the Sun that are about 17 times stronger than the Moon's on Earth. Combined with a 3-to-2 spin orbit resonance of the planet's rotation around its axis, it also results in complex variations of the surface temperature. The resonance makes a single solar day. The length between two meridian transits of the Sun on Mercury last exactly 2 Mercury years, or about 176 Earth days. Mercury's orbit is inclined by 7 degrees to the plane of Earth's orbit. The ecliptic, the largest of all 8 known solar planets. As a result, transits of Mercury across the face of the Sun can only occur when the planet is crossing the plane of the ecliptic at the time it lies between Earth and the Sun, which is in May or November. This occurs about every 7 years on average. Mercury's axial tilt is almost zero, with the best measured value as low as 0.027 degrees. This is significantly smaller than that of Jupiter, which has the second smallest axial tilt of all planets at 3.1 degree. This means that to an observer at Mercury's poles, the center of the Sun never rises more than 2.1 arcminutes above the horizon. At certain points on Mercury's surface, an observer would be able to see the Sun peak up a little more than 2/3 of the way over the horizon, then reverse and set before rising again, all within the same Mercurian day. This is because approximately 4 Earth days before perihelion, Mercury's angular orbital velocity equals its angular rotational velocity, so that the Sun's apparent motion ceases. Closer to perihelion, Mercury's angular orbital velocity then exceeds the angular rotational velocity. Thus, to a hypothetical observer on Mercury, the Sun appears to move in a retrograde direction. 4 Earth days after perihelion, the Sun's normal apparent motion resumes. A similar effect would have occurred if Mercury had been in synchronous rotation. The alternating gain and loss of rotation over revolution would have caused a libration of 23.65 degrees in longitude. For the same reason, there are 2 points on Mercury's equator, 180 degrees apart in longitude, at either of which, around perihelion in alternate Mercurian years, once a Mercurian day, the Sun passes overhead, then reverses its apparent motion and passes overhead again, then reverses a second time and passes overhead a third time, taking a total of about 16 Earth days for this entire process. In the other alternate Mercurian years, the same thing happens at the other of these 2 points. The amplitude of the retrograde motion is small, so the overall effect is that, for 2 or 3 weeks, the Sun is almost stationary overhead, and is at its most brilliant because Mercury is at perihelion, its closest to the Sun. This prolonged exposure to the Sun at its brightest makes these 2 points the hottest places on Mercury. Maximum temperature occurs when the Sun is at an angle of about 25 degrees past noon due to diurnal temperature lag. At 0.4 Mercury days and 0.8 Mercury years past sunrise. Conversely, there are 2 other points on the equator, 90 degrees of longitude apart from the first ones, where the Sun passes overhead only when the planet is at aphelion in alternate years. when the apparent motion of the Sun in Mercury's sky is relatively rapid. These points, which are the ones on the equator where the apparent retrograde motion of the Sun happens when it is crossing the horizon as described in the preceding paragraph, receive much less solar heat than the first ones described above. Mercury attains inferior conjunction, nearest approach to Earth, every 116 Earth days on average. But this interval can range from 105 days to 129 days due to the planet's eccentric orbit. Mercury can come as near as 82,200,000 kilometers. 549 astronomical units. 1 million mile to Earth, and that is slowly declining. The next approach to within 82,100,000 kilometers, 51 million miles, is in 2679, and to within 82 million kilometers, 51 million miles, in 4487. But it will not be closer to Earth than 80 million kilometers, 50 million miles, until 28,622. Its period of retrograde motion as seen from Earth can vary from 8 to 15 days on either side of inferior conjunction. This large range arises from the planet's high orbital eccentricity, essentially because Mercury is closest to the Sun. When taking an average over time, Mercury is most often the closest planet to the Earth, and, in that measure, it is the closest planet to each of the other planets in the Solar System.